Hi, welcome to this lesson on trigonometry compound angles. Let's have a look at question 3. We're given a restricted domain of 0 to 360 degrees inclusive, and we want to solve for all angles x that satisfy this equation. So now we have root 2 times sine x plus root 2 times cos x equals negative 2. So at the surface, it doesn't look like much is going on. But whenever we have sine and coses together, we should always try and make use of one of the compound angle formula to help us solve the equation. So now I see root 2's and 2's there. Now the first thing my mind thinks of when I'm doing any trigonometric ratios is the numbers 2 and root 2's have a very special type of relationship when it comes to trigonometry, namely special angles. Okay, so what I'm going to do first is I'm just going to divide both sides by 2. Okay, so I'm going to get root 2 over 2 times sine x plus root 2 over 2 cos x equals negative 1. Okay, I've just divided both sides by 2. Now, root 2 over 2 is very interesting, okay, because root 2 over 2 is a special angle. It's cos of 45 degrees gives you root 2 over 2. Sine of 45 degrees also gives you root 2 over 2. Okay, so those are very, very special angles. Okay, so we can check there. Sine of 45 degrees, root 2 over 2. Cos of 45 degrees, root 2 over 2. So I can rewrite this equation in a very smart way. So instead of root 2 over 2, I'm going to put it as sine of 45 degrees times sine of x plus, instead of root 2 over 2, I'm going to put it as cos of 45 degrees times cos of x equals negative 1. So that was essentially the most difficult part of this equation, was figuring out how we can rewrite it to look like a compound angle formulae. And the key is to always try and check for special angles, things you know, 30 degrees, 45 degrees, 60 degrees, 90 degrees, 180 degrees, 270 degrees, all these special angles we've worked with before. Okay, so what do we have? We have sine, sine, and cos, cos. Well, which one looks very close to that? Well, I remember the cos of a minus b, that was cos, cos, sine, sine, then the angles as we saw them, AB, AB, and then the minus became a plus in the middle. So I'm going to rewrite this as cos x times cos 45 degrees, which I can, right? Multiplication is commutative, I can swap the order, plus, and as well as addition is commutative, so I can swap the order of the addition. And then in here, I'm also going to swap the order of multiplication. It's going to be sine x times sine of 45 degrees equals negative 1. So that's exactly what we have here. Cos, cos, sine, sine, AB, AB. So this implies that this becomes cos of x, because of the plus sign, minus 45 degrees equals negative 1. So now we just have a simple trigonometric equation that we can solve. So let's get our cos diagram up. Now, cos is negative in the second and third quadrants, and we need a reference angle. So in the second quadrant, it's going to be x minus 45 degrees equals 180 degrees minus the reference angle, plus k times 360 degrees, because that's the period of cos. And then in the third quadrant, it's going to be x minus 45 degrees, the angle, equals 180 degrees plus the reference angle, plus k times 360 degrees. So what's my reference angle? It's going to be cos inverse of positive 1. And we saw that the cos inverse of 1 is going to be 0 degrees. So my reference angle is 0 degrees. So that's going to be 0 degrees and 0 degrees. So now if I solve for x, if I add 45 to both sides, that's going to be 225 degrees plus k times 360. And again, if I add 45 degrees to here, you can see we end up with the same equation again. Okay, where k is an integer. Alright, so now we can just put integer values in and check in that given domain what solutions we get. So when k is equal to 0, I'm just going to check quadrant 2 because quadrant 3 is exactly the same equation. So k equals 0, I get 225 degrees, which is inside that domain. if I put anything bigger than or equals to 1, there'll be no applicable solutions in that domain because we'll have values outside of 360 degrees. And then if I put anything less than equals to -1, okay, so that's going to be 225 minus 360, that's going to give you a negative angle, so it's not applicable. It'll be less than 0 degrees. So the only applicable angle in that domain should be 225 degrees. And again, we can go ahead and double check this. So I'm going to put in the very original equation, root 2 times sine of 225 degrees plus root 2 times cos of 225 degrees. And we get -2. Alright, so that's how you can double check that your solution is correct. Alright, that's how we do this type of question. I'll see you in the next one.